Well, hello Internet, and welcome to part 1 of my UML2 video tutorial. Today I'm going to talk about the basics of UML, or the Unified Modeling Language, as well as show you what a use case diagram looks like. Now, UML is just a graphical way of describing software systems, that's all it is. And there's going to be basically two types of UML, sketching and blueprints. Whenever you decide you want to go through a UML sketch, your major goal here is just to communicate an idea, sometimes to laymen that do not know anything about programming. And you basically just want to use it to rough out ideas and go through different alternative approaches that might make sense. In this situation, your aim is not to be specific, but just to get your basic ideas out in front of you so that you know what you really have to accomplish in the creation of this system. Then you have the UML blueprint. These, on the other hand, are going to be very detailed, and they're going to contain all kinds of design decisions that a programmer very well might be able to directly translate into code. Then we're going to get down into this, which is known as the model-driven architecture. And this is either going to be platform, independent, or platform specific. And I'm guessing you probably understand what that means, but either way, platform independent, of course, would be a UML model that is independent of any specific technology or any specific language. However, on the other hand, platform specific, of course, would be model specific to an execution environment or a chosen programming language. Then we get into the development process. You're basically going to have two different ways of developing a UML diagram and your system in general. You're going to have the waterfall way to break up a project, and in this situation you're going to complete the following in order: analysis, after analysis complete, then on to design, and then on to coding, and then finally, after those three are complete, you're then going to move into the testing process. So everything is completely done in order before you proceed to the next one. The iterative way to break up a project, however, solves all of the different pieces of your project in pieces. So you're going to define the different pieces of your functionality of your system right from the beginning, and then you're going to go through the process of analysis, design, coding, and then testing on each of these individual pieces before you move on. In most situations, the iterative way is going to be preferred over the waterfall way, and that is just simply because most of the time when you're building a system or a program of any kind, you're going to have all sorts of changes just come up that were not predicted in the beginning of the system. So just plan on using the iterative way, because the waterfall, while it is preferred in many situations, more than likely you will not use it. Then we get into the planning process. Here we're either going to be predictive or adaptive, and a predictive plan is just going to be a plan for the whole entire project that is going to be created at the very beginning of your project, and every single person is going to be involved and on the same page, and it's just going to be peachy keen and very easy to work with. As you're probably guessing, this is not often used. Then we come to the adaptive planning process, which is what you're going to use most of the time. In the adaptive planning process, you're going to treat change to your requirement lists as just being inevitable. And as an adapter, you plan on working with users continually throughout the process to continue to add additional functionality. And if you plan on using the adaptive planning process, to a certain extent, this is known as agile development. And it basically comes down to this: if you can very, very easily, in a guaranteed manner, list out your requirements and you're almost 100% sure they are not going to change, use the predictive planning model. But as you're probably guessing, the adaptive planning model is what you're going to have to use whether you want to use it or not. And now we're going to get into the meat of this whole tutorial, which is going to be use case diagrams. A use case is just going to define how your program will solve a problem or provide some level of functionality. And use cases define what is required of your program and how those requirements will be met. Now, of course, you're not going to try to write code, as you're going to see here in a split second, with a use case diagram. You're just going to look at everything from a global perspective and pretty much narrow down on what exactly you absolutely have to have. And that comes to requirements. Now, you're going to have two types of requirements. You're going to have shall requirements, which are going to be requirements that are required for a project to be considered completed. Then you're going to have should requirements. Those are going to be requirements that are going to be considered useful, however, they are not critical. So what you need to do whenever you're working through a project is get the shall requirements out of the way and guarantee they are done, and then worry about the should requirements if you have any more time left. Now, whenever you're creating your use case diagrams, all of the steps that you're going to be listing are normally going to include interactions with actors, and these are either going to be human or external systems, as you're going to see here in a second. And here is a very basic use case diagram. Now you're going to come up with, there's all sorts of jargon terms that you're going to hear about a whole bunch of times. If you ever hear about a stereotype, what this does is it just describes the role of an element. And they can be either people or systems or what have you. And we actually have a couple stereotypes here. One right here is a little person. And this stereotype is going to be representing the bank customer in this situation. Also, this guy's here is known as an actor, as is bank security, which you can see on the right side of the screen. Now, whenever you're defining actors, you can either draw them as little people like we have here on the screen, or you can put their name right here inside of what is called a guillemot. And you would do this, of course, if you'd like to save yourself some space, which who couldn't use more space? Over here, this is known as a note, and this is a symbol for a note. And inside of the notes, you're going to provide certain comments, a lot more information than bank customer, but maybe not. And they also, these notes can be known as tagged values. So let's say that we wanted to put bank customer inside of here, but we also wanted to connote that we would like the bank customer name or account number or whatever to be assigned inside of here to better represent this little character that's right here. We could, of course, just put bank customer inside of here, inside of a guillemot, and then list out all of those different tagged values that we would like to associate with this element. And this isn't ironclad stuff here. You can kind of bend it and make it look the way that you want it to look, but this in general is what a use case diagram looks like. And this is a use case. Anytime you create a use case which must accomplish some sort of task inside of your system, you're going to surround it, just like I have right here, with an ellipse. This guy right here is known as a communication line, and all it does is connects your actors to your use cases, right like that. This great big giant huge box right here is what is known as a system boundary line, and all it does is it surrounds your system and separates your system from actors, which are on the outside of the system boundary line. Right here, you can see the word include, and what include means is you use this whenever you want two or more elements to use a use case. Like right here, whenever they insert their card, we're going to verify the card. And also whenever they enter their PIN, we're going to verify their card. So this is a use case that is going to be shared completely by these other two use cases right here. And hence we're going to say these include verification of the card. Extend, on the other hand, is used whenever a use case is optional. So here, let's say that we try to verify the card and we decide it is not a good card. We can here decide to extend and mark this as a stolen card and either eat it, destroy it, or whatever. However, we are not required to do that. So that's what extend is. It's extended functionality. However, it is not needed. Hence, that's the reason why it says extend instead of include. And then finally, down here, I'm showing you a general use case, and you use the little diagrams and arrows just as I have right here. So let's say they want to come in here, the bank customer, and select an amount. Let's say an option or a more specific use case would be that they would select amounts in the values of tens or $20 increments. This would be considered a general use case, while these would be considered more specific use cases. So that is basically all that you need to know to understand use case diagrams, except for the fact that most of the time whenever you create a use case diagram, you're going to first create a use case description. So let's take a look at one of those. Now, whenever you create a use case description, of course, one of the parts of that is going to be the description. And I'm not going to read all this, but basically it just goes through and goes over all the different things that your system's going to do. Like the user enters their card and PIN, security verifies the card, the user selects the account to use, and blah, 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 blah. Whenever you are creating a use case description, part of that would make a lot of sense to include would be a description of the overall system. Then you're going to list a trigger. And this is just what is going to happen before your system is triggered. Hence, the machine receives a card or the user enters a PIN. You actually technically don't even need that part because the system automatically starts as soon as a card goes into it. And that is what is called the trigger. Then you have what are called actors. These are the people outside of your system boundary lines, and as you saw previously, those actors in this system are both the customer as well as bank security. Then you're going to list preconditions. These are going to be conditions that absolutely must must be true for your system to be able to start operating. So, of course, they're going to need a secure connection to the bank, and that bank or ATM machine needs to have cash. So those are two conditions that must be true, otherwise your system really shouldn't even start. Then we get into goals or successful conclusions. Sometimes people actually break these into two separate parts, but in this situation I'm just going to list them as one. Under goals, we want to first make sure that our client accounts are secure, and secondly, provide the customer with funds if we have them on hand. So those are our two goals, and I'm just breaking everything down into pieces. Then you're going to list all of your failed conclusions. These would be situations in which your system has failed or has ended processing before it would go through the entire use case. If they enter an invalid card, of course that's going to end it. If they enter an invalid PIN, of course that's also going to end it early. If the customer has insufficient funds, or the ATM has insufficient funds, or they're over their daily limit, this would be another situation in which we would not be able to process through our entire use case. Then we have extensions. And often extensions come from the different parts of your use case diagram that use the extend word. These would be situations like a PIN is entered 3 times incorrectly and you eat the card, or the card is marked as stolen and you eat the card. So, use these things as you would like. And then finally, you're going to have your steps of execution. Again, these are often listed both as steps of execution and on a separate list as requirements, but in this situation, I'm just going to show steps of execution because this is a pretty simple process. So we have customer inserts card, and then I'm going to mark off all of these additional things that could happen. Card is invalid, eject a card, whatever. And I'm basically going to try to list out all of the possible things that could happen throughout my system. Card is validated, customer enters PIN, however, PIN is invalid, or PIN is invalid 3 times, or card is marked as stolen. These are different things that could occur and mess up during stepping through the execution of my system. However, if the PIN is valid and the account is selected and the amount is selected, and they are not over their daily maximum or over the account funds that are available to them or over the funds available to the machine, we are then going to proceed through all of these additional steps. So that is a basic use case diagram as well as a basic use case description. As this tutorial continues, we're going to get more and more complicated. So of course, feel free to leave any questions or things that you want me to cover in the future. I want to end this tutorial by saying that right now the next tutorial that's going to follow my UML2 and my refactoring tutorial is either going to be an Android's games / C programming language tutorial or a Java Enterprise Edition with development frameworks and everything else you see on the right side of the screen. If you would like to see one of these tutorials over another, underneath the video there is a link where you can click and vote on it. I'm going to keep the voting open at least for a week, so feel free to vote if you have any interest in this. And if you don't, feel free to leave any questions or comments below in regards to the current tutorial. Otherwise, till next time.